A very good morning, good afternoon, or good evening, wherever in the world you happen to be, and welcome to today's webinar, which takes driving operational excellence in maritime challenges and innovations as its theme. The webinar is brought to you in proud association with Orca AI and Deep Sea. Now, ladies and gents, just before we get underway, I want to share with you key information that will support you in getting the most out of proceedings. First of all, please be assured we will direct you to the recording and the materials after the webinar. Please submit your questions at any time because we do Q&A throughout the webinar, and any questions that we don't get to, we commit to coming back to you in writing within a week of transmission, meaning there's every reason for you to get involved and send through your questions, confident you're going to get answers. Please stay tuned into the end so you don't miss out. I guarantee our high-level panel will be sharing powerful, original, and exclusive insights of real benefit to you and your operations. So do stay tuned. At the end of the webinar, I'll be circulating a link to an exit survey. Please take the couple of minutes to complete it, and in turn we'll direct you to the presentations and recording. For enhanced viewing, please use the latest version of Microsoft Edge or Google Chrome, and in the unlikely event you lose sound, simply refresh and it will return. A word or two, ladies and gents, about your hosts, Riviera. Riviera Maritime Media is a maritime and offshore information specialist active in 4 areas: news, events, jobs, and data. To learn more, please visit the dedicated website, www.rivieramm.com. Well, ladies and gents, this is me, Edwin, and I'll be moderating proceedings today. And speaking of today, this is the ground we're going to be covering: advanced connectivity in maritime operations, transformation of maritime operations, delivery of real-time insights, empowerment of impactful data-driven decisions, seamless enhancement of efficiency, and from the bridge to the engine room. This is our agenda, or in other words, how it's going to go. Presentations will be run consecutively and followed by open discussion. Please do submit your questions at any time because, as you know, we do Q&A throughout the webinar. At the end of the webinar, we'll share key takeaways and conclusions, and we'll also preview what's next. Well, what's next for us is to meet our high-level panel. I'm delighted Cameron is here. Cameron Mackey, he is COO with Scorpio Group. Also here today is Patrick Ryan. Patrick, of course, is Senior Vice President and Chief Technology Officer with ABS. Yarden, of course, is here, Yarden Gross. Yarden is co-founder and CEO of Orca AI. And completing the set is Roberto Custos, co-founder and president, Deep Sea AI. Geir from Wallenius Wilhelmsen will not be joining us for this webinar. Throughout the course of the webinar, ladies and gents, we will certainly find time for a poll or two. And as you know, we really value your questions, so please fire them in at will via the webinar chat. Ladies and gents, thanks for joining us today, and in such numbers and from all over the world. It's high time we got underway. So with that said, Yarden, as and when you're ready, the floor is yours.
Thank you, Edwin. Thank you, Edwin. It's a pleasure to be here with the distinguished speakers. And thank you for everyone who joined us to hear a little bit about how we're looking at technology, AI, and how it's going to impact the shipping industry, and actually why it's driven also because of connectivity. So my name is Yarden Gross. I'm the co-founder and CEO for Orca AI, and it's a pleasure to share with you, my thinking about how the industry is going to go forward. So we all know the shipping industry is, the lifeline of global commerce. It's the backbone of global supply chain, moving 90% today in the goods in the world. It's impacting our daily lives in every aspect, but in a way it's been operating in the last couple of decades in a very conservative manner. Low technology adoption, a lot of operational challenges that happened and been compounded over the years, everything from safety, fuel cost, regulations around emissions today, shortages in crewing, and no technology that actually enabled to solve those type of problems. And what we see today and what we understood is that ships will become more connected to the cloud. And once you have connectivity, then you'll be able to deploy more technology on board. You'll be able to collect data in scale directly from the ship sensors to the cloud. And then AI will be able to train on those type of data. New models will form. And those AI models will be able to be deployed on board the ships to improve operations, enhance the crew capabilities to do their job in a better way, and actually impact the bottom line of shipping companies and ship owners across the globe. When you combine the new type of connectivity plus the advance of AI, and also a very important component, which is the crew mind shift, new generation of crew that are operating ships today, they're more used to use technology, they're more open, less resilient technology. Everyone are actually using smartphones today on board. So they're more open to utilize technology and to actually extract value out of it. So why connectivity is a crucial component when we're talking about AI and to be able to implement AI on board a vessel. Everything starts with data and data collection. Data is very similar to our human being as an experience. So very similar to how we drive in our car. Over time, we're gaining more experience because we gain more situations, more data related to how to drive in different type of scenarios. So very similar here. When you want to build an AI model, which is very robust, you need to collect a lot of data. The data is being collected in scale. Once you have connectivity, it's going up to the cloud. Once it goes to the cloud, then it's going through a certain process, which is basically transforming raw data into a data set. The data set is data that is actually ready to go through a certain training mechanism to take the model, to training on the data, to get better performance and better capabilities. Once you have a trained model, which went through the entire testing, then it can be actually deployed back to the ships. So if you think about it, it's like a cycle that constantly, compoundedly getting better, which more data you have, you're building better capabilities that you have, you can actually deploy it back to, will expand your offering, you will get expansion in terms of more ships, then you will get more data. Today, Orca has about 55 million nautical miles of data that we've been collecting. And this has enabled us to actually build models, robust models, to improve operations on board, to enhance the capabilities of the crew, to take better decisions. Now, when you look at the new generation, how over time you're creating better type of models, this is just an example. So example of detection algorithms, perception algorithms that over time been trained on more a new type of data, and over time been getting better performance to be able to detect smaller targets, to be able to detect different type of targets. So you can see, for example, here between 5th generation detector that we used in the past to 6th generation detector. Now we're actually already in the 10th generation. But you can see that over time, gradually, how the models are actually improving based on more data that you're collecting. When you're combining all of that together, and this is the last step, is to take the models, combine them to one product, and building a product around the models that will be able to provide insights to the code, that will be able to provide value to the users. So this is actually how it looks with the perception capability, situational awareness based on vision sensors, plus combination of fusing from radar information, AIS information. This is how it looks actually under the hood. So a lot of complication, everything from to be able to calibrate the platform in real time, to be able to deploy AI algorithms that are able to detect targets in the very high accuracy, to be able to measure distance, to be able to understand how the targets are actually implying risk on the vessel, and to be able to create an alert system that will provide actionable insights to the crew related to safe navigation and to improve their operation on board in terms of operational efficiency. Eventually, everything needs to look very clean, very understandable. So the product, when it comes and serves to the user, would look in a different way. So very, like a lot of complication in the back end, under the hood, very simple how it looks in the front end. So this is just an example of how it looks between line of sight to how it looks with the Orca platform. I'm showing you one example, a part of the platform that actually describes and shows how thermal cameras with a combination of perception capabilities, perception algorithms, can actually enhance the crew capabilities to be able to sail in a safer way, in a more efficient way, in those very complicated waterways, for example, in China waterways in the middle of night. Another example is English Channel in the fog. Again, combining between thermal cameras with perception capabilities becomes a very powerful tool that enables the crew to sail in a better way, in a more efficient way, safer way. And this is really increasing the crew confidence, increasing their abilities to take better decisions. And we see that across the board today with many vessels that are actually deployed Orca and using it on a daily basis. So we believe that AI should be a platform. It's not just one feature or one capability. AI should be a platform on the same type of data that we're collecting and actually providing capabilities to different type of users. First of all, from our perspective, is to provide real-time insights to the crew to enhance and to empower their capabilities to sail in a safer way, to improve their operational efficiency on board the vessel, to automate actually parts of their tasks that they need to see, for example, the watch-keeping tasks. But then at the same time, also creating visibility and providing actionable insights based on AI algorithms that are creating, for example, perception, that are creating, for example, predictions in terms of what type of actions you need to take related to the entire fleet. If you need to change, for example, internal policies, if you need to monitor specific actions, and to be able to pinpoint how to improve the operation on board the vessel. But the most important part is that everyone will work on the same type of platform with the same type of data set and different type of algorithms that improve the operation. We see already across the board customers that are already deploying AI, partners like leading shipping companies in different verticals, and we see tangible impact that is happening across the board over time. If it's tangible impact in improving safety, if it's tangible impact related to fuel efficiency, to be able to show impact on the bottom line. This is what is important. AI is here to improve operational efficiency. It's here to improve automation, reduction in cost, but eventually it needs to go down to the bottom line of the company, show how it's tangible and it's measurable, and the customers can actually, or shipping companies can actually improve the operation and to be more competitive in this industry. Back to you, Edwin. Thank you very much.
Thank you very much indeed. Great presentation to get us underway, which has started to stimulate some questions. Ladies and gents, do keep your questions coming. More immediately, waiting in the wings, we have Roberto. So Roberto, at the point you see your presentation on the screen, the floor is yours. Roberto, we will of course need you to unmute yourself.
Yes, of course. Sorry, just a minor detail. I was just saying thank you very much, Edwin, and thank you very much, Yarden, for the presentation. My name is Roberto Custas, and I'm co-founder and president of Deep Sea Technologies. And today we're going to talk about the foundation of efficiency and how you can't improve what you don't understand. And very much also in the same sort of context as what Yarden mentioned, how important data is in order to help us understand how our vessels operate and therefore use that as a bedrock in order to improve their efficiency. So the first question that many people might have is, why now? Why is now the important time to actually take action and step up their digitalization strategy? And the reason is there are new regulations being introduced all of the time with the EU EUTS and many others. And that means that there's increasing commercial pressure, increasing regulatory costs, and also at the same time, companies not only have to comply with increasing regulations, which is becoming harder and harder every year, but also we have to navigate in this very uncertain alternative fuel landscape. And that means that the transition to greener fuels or to a more, let's say, environmentally efficient operation is going to be very expensive. And the best way to navigate this expense is actually to use artificial intelligence. So currently, we live in a low visibility world. So most vessels around the world, as I'm sure you're very familiar, use noon reports once per day to understand the vessel behavior. So the captain sends once per day an email to the headquarters of the company outlining what the speed of the vessel was, what the weather conditions were like, and many other parameters. And this is problematic because in a low visibility world, the different stakeholders can't have a clear view and to agree on how the vessel is actually operating. And this creates disputes with the charter party warranties. It impacts decisions on retrofits, voyage planning decisions, and many, many others. Very interestingly, we recently did a survey and discovered that on average, shipping companies have a 15% insight error. So what that means is when companies are asked to predict their, let's say, daily fuel consumption or to estimate what their daily fuel consumption was without knowing it, the uncertainty was 15%. And the reason why this is very important is because you can't improve what you can't measure, as we stated in the beginning of the presentation. And what that means, if you have a 15% insight error, it means that there is no way that you can be very specific and accurate into the decisions that you're making every day. And what that means for the bottom line is that essentially a lot of fuel is wasted and a lot of CO2 is unnecessarily being emitted to the environment. So just to give you a ballpark example is that the optimization potential of the heart of your organization could be around $40 million for a 100 vessel fleet. And these are numbers that are backed by many companies such as Wallenius Wilhelmsen, EPS, that we've done joint research together. So I'm sure you're aware of the current status quo of measuring performance. This is a very standard sea trial test that a shipyard will, of course, provide at the new building stage. And of course, these tests can be repeated throughout the life of the vessel. But these are problematic for two reasons. So first of all, shipyards tend to use many different types of sensors and select the measurement that is most convenient for them. That's the first problem. And the second is that these capture the behavior of a vessel at a very static point in time. And as we are very well aware, vessels are dynamic and they change every year. And even if they stay idle for a month and there's fouling buildup on the surface of the hull, that means that the behavior of the vessel instantly changes. So what we are looking for in this world that moves as fast as it does is a method to capture real time the ongoing change of the vessel and use that information to our advantage. And essentially what we do at Deep Sea, because I think AI is, of course, at the pillar of everything that we do. But what is unique with our approach is that we merge naval engineering with AI. So what that means, as of course Yarden mentioned before, it's important to collect a lot of data as when you're driving a vehicle to build a lot of experiences. But what tends to happen a lot of the time is that vessels operate in very specific conditions. And that means that we very often don't have a view of what happens outside of the things that we have seen or witnessed with a specific vessel. And that is where the naval engineering comes in. We're using AI to understand really accurately the vessel and the conditions that we have seen. And we're using naval engineering with AI to extrapolate in conditions that we haven't seen from the data, but are very crucial in order to optimize holistically the vessel or an entire voyage. So this is an example of what AI essentially does, because it might sound very daunting, but it really isn't. So what AI does, and is very capable at doing really well, is taking all of these input parameters, such as the wind, the speed of the wind angle, current angle, swell height, also all of the weather conditions, fouling state, speed, draft, etc., and many more parameters, salinity of the water, and everything that impacts the performance of the vessel. And we're able to gather all of that information and simplified it into one very important metric, which is the fuel consumption. Because at the end of the day, all we care about is how can we minimize the fuel consumption of our vessel by either selecting a more, let's say, environmentally friendly path for the vessel. So we minimize, let's say, the wind or the wind angle or the current that the vessel has to go through to minimize fuel consumption. Or how can we change other parameters in our control, such as the fouling state, in order to minimize fuel consumption. So it is important to just backtrack and look at traditional performance modeling techniques. So the problem with all of these techniques, such as fuel tables, sea trials, CFD analysis, or towing tank tests, is that there very often needs to be a compromise. So the compromise might be that fuel tables might not be very highly accurate, but it doesn't require off-hire period and are not very expensive. Sea trials are across the board, I think, very, very difficult to replicate and quite expensive as well. CFD is very accurate, but again, quite expensive, and also does not take into account very different weather conditions. I'm sure all of the engineers here will know that the more turbulent the conditions become, the less accurate the CFD analysis becomes. And the towing tank tests also are not something that can capture, for instance, the fouling state of the vessel. And that's where artificial intelligence comes in. It is the only method that doesn't need to compromise on any front and is also not expensive at all compared to all of these other methods. So to give a testament to the accuracy of the AI, you don't have to take our word for it. We always like when our clients can testify to our joint successes. So this is an example from Eastern Pacific Shipping, where we jointly ran a per week prediction of fuel consumption against the actual. And we saw that the accuracy was in the ballpark of 0.8 to 1% when the quality of the data was good. And of course, as we would expect, when the data quality was poor, that increased to about 5%. But then again, it's a lot lower than the 15% average uncertainty that we have witnessed in the market. And to give another example by another of our clients, Wallenius Wilhelmsen, which we have been working jointly together to drive down the fuel costs of their entire fleet and increase their environmental awareness and consciousness, is that we have jointly been able to achieve by understanding better the behavior of the vessels. We've been able to drive a 7% almost voyage efficiency increase, and that means that on average, we're saving $2,000 per day per vessel. There's a 26x ROI. And all of this benefit, again, is achieved just by harnessing data that is already there. Because the data is generated even if we capture it or not. It's on the vessel. And all we're doing essentially is we're capturing that information and we're using sophisticated AI algorithms to use that information, understand how the ships are running, and give you the insights and the benefit of that data to drive better decisions for your organization. We are very well aware that AI, again, as a word, can sound very daunting to people who are not necessarily familiar with what AI is. But the process, like with anything, becomes a lot less daunting if we take a very structured approach to it. So, as we say, it's best to begin the process early, and we have to identify the highest impact innovations, and that takes around 6 months. And then after we identify and create a business case together, we start enabling optimization for the entire fleet, and then we can have a wider adoption across the organization so that everyone uses the same information. Because a problem that many times exists is that information within large organizations is very fragmented. And what that means is that if there's, let's say, a fuel table that's created in the technical department, that might not necessarily be translated to the operations or to the chartering department. What we're able to offer is a transformation and transparency of information throughout the entire organization. So thank you very, very much for joining and for your time. And if you have any questions, I'll be very happy to answer them. Yes, after this presentation. Thank you. Back to you, Edwin.
Thank you very much indeed. There are questions for your account, so I encourage you to familiarise yourself with those. More immediately, waiting in the wings, we have Cameron. Cameron, I will retrieve your presentation, ask you to unmute yourself, of course, and then the floor will be 100% yours.
Great, thank you, Edwin. Let's go to the next slide, please. What I'm going to be speaking about today is ergonomics. It, I think, offers a very helpful framework and lens through which one can evaluate different solutions and different changes to an organization or a set of systems. In short, ergonomics just means how humans interact with systems. Those might be systems largely based on technology, might be based on processes, they might be systems of people interacting with other people. But oftentimes, systems can get very messy, and systems overlap with other systems and impact other systems. And so what we're left with is a hodgepodge of different solutions and different processes and different subjectivities, which can lead to a lot of bad outcomes. Moreover, when someone wants to introduce a new system, an improvement, or any change, generally the human response is confusion, stress, and anxiety. So that in order to improve a system, you have to endure a less effective system for the short to medium term, and sometimes even longer. Edwin, let's go to the next slide, please. We're going to talk, because it's unavoidable, we're going to talk about money and how we should evaluate the risk-adjusted returns of our investments. Different owners and operators will have obviously different time horizons. They'll have different return hurdles. They'll have different pressures on capital, whether they're public or private. And oftentimes what people forget is how cycles in our industry normally occur. It is not a simple curve like you see on the top, where you have these lovely, predictable periods of outsized profits followed by a period of deficits. It's much more like a human heartbeat, where you have long periods of slow capital destruction, of near break-even rates where the weaker operators and owners are falling into distress, and then a spasm in the market driven by very profound catalysts that drive outside returns. So notice in the bottom picture, which is loosely based on a long-term chart of VLCC rates, that period of long quiet is generally below the weighted average cost of capital. And so through that prism, you have to evaluate what investments you're going to make and how you're going to survive until you get to the next period of outsized excess returns. Let's go to the next slide, Edwin. Here's a question, and you probably know the answer to this. Which tabletop is bigger? They're actually both the same size. Which line on the right is longer? They're, again, both the same size. So this is a way of saying, when you talk about optimization, the real important question is, what are you optimizing for? I think it was mentioned earlier, in any optimization exercise, there are going to be assumptions, there are going to be compromises. Optimization doesn't work well with ambiguity or dilemma. And you need the users of a system really to understand what one is optimizing for and what the model limitations may be, whether those might be more type 1 errors, type 2 errors, whether there might be assumptions, certain assumptions that the future must look like the past, and how far back the model is looking. So these are very, very important considerations when one is looking at improvements to a system. Let's go to the next slide, Edwin. Edwin, great. Here is a safety management system. This could be literally on the bridge of a vessel, where one has to refer to outdated policies that overlap or contradict with each other, just to try to understand what's going on. What I'm getting at here is, when you have systems that are resting on antiquated or obsolete procedures, they bear very little resemblance to what is actually happening on a vessel. And so I think a lot of great owners and operators have been able to invest all along the way, but one has to appreciate that all this knowledge cannot be carried in the head of a master or chief engineer. That there is only so much bandwidth that a ship management or safety management system in practice has between the stresses, physical, emotional, and otherwise, to actually implement a process on board. Let's go to the next slide, Edwin. Like all systems, their utilization is limited to the upside. So existing shipboard systems, particularly where human input is required, really start to come under stress when they get to about 80 to 90% utilization. And then they become unworkable. So what has happened in the last 20 years is that additional requirements, whether they're regulatory in nature, or maybe they're opportunistic, like the availability of internet and social media to your crew. When those things are introduced to the ship, it's not something that can easily be absorbed. Usually something else is getting crowded out. For example, hours of rest, or judgment, or alertness, or teamwork. So all of these stresses start to really come about in the last 20 years because of the stresses on maximum capacity of onboard systems. Next slide, Owen. Finally, we're going to talk about symmetry because many models, human models, not necessarily technological models, rely on symmetry and symmetrical distributions. And what we all know is that the outcomes in our industry and on our vessels are not symmetrical all the time. So the judgment of the users of different systems have to be very aware of asymmetry, something that's not intuitive. It's quite counterintuitive. For example, when one is making a navigational decision, what is the downside? The upside may be 1 or 2 minutes on an ETA. The downside may be a catastrophic failure or misunderstanding. So the understanding of asymmetry is critical as we look at different systems and system improvements. Next slide, please. Here's downside. Here's downside. Thankfully, nobody was killed in this incident. This goes back to 2006. But this was a case of competing priorities and a system that got overstretched. What happens is something called cognitive dissonance, where users of a system get mixed signals. And in their confusion, they make errors. And in addition, maybe they're tired. And in addition, maybe they're under some commercial pressure. So in conclusion, what I'm doing is not really talking about the opportunities. I think Yarden and Andreas are talking great about what's going on and what the opportunity set is. But what I would say is that we don't call it AI, we just call it thoughtful technology, because the most thoughtful technology can start to reduce the stressors and the stresses and the utilization of onboard systems which are already at their breaking point. And that's how we look at things. Edwin, back to you.
Thank you very much indeed. A great presentation, which has stimulated some questions. Our final presenter today, of course, is Patrick. Patrick, at the point you see your presentation on the screen, the floor is yours.
All right. Thank you, Edwin. And good morning, good evening, good afternoon to all the participants. Thanks for joining today. It was my pleasure to talk about the way class looks at artificial intelligence as it approaches the market. So first, let me open with giving kind of the class perspective on the broad use of AI in the maritime industry. As we see it, where we see applications or the leading uses for operational use of AI is in enabling autonomy. Autonomy, a term often that needs some clarification. So we're not talking about just unmanned platforms and not just navigation. although these are the applications that tend to really, capture everyone's imagination. But we are seeing more and more requests for autonomous function approvals, certifications, really outside of these to kind of a broad system level. And that range goes from partial automation to remote control to unmanned systems, and whether that's sensor fusion or regression analysis or beyond. Today, we think this is really the most obvious use of AI. Now, next, we see lots of AI use in inspections and survey. This is where we think that AI-based image and video recognition technology really starts to separate itself. For what it's worth, AI image and object recognition were some of the first applications employed by ABS and our adoption of AI technology. And we do see image processing in many new applications going beyond inspection to things like security, ergonomics, as mentioned, safety, and beyond. And of course, really the biggest discussion going on in the industry today is the green energy transition. And so, as we look for technologies to really help society overcome that challenge, AI certainly has a role to play there as well. So at ABS, getting a little more specific, we're committed to enhancing our own digital presence and improving customer engagement, of course, through innovation. And one of those big programs is the ABS condition-based program. Now, this was first launched for our government clients back in 2022 with the first of its kind class guide condition-based programs for government vessels. Really, it began by leveraging natural language processing to review and summarize maintenance records and those noon reports that I think it was Roberto that mentioned, and really, leveraging not only that and digitizing those in a way that the computer could consume them, but leveraging machine learning on sensor readings for rotating machinery and looking at as many data threads as we could from a structural standpoint. So typically we're talking position, speed, weather, and then structural data, which would include wastage measurements and our computational models to really predict structural health, all getting to a rule compliance type of solution. Using AI for us really helps us to predict compliance. And where we want to get to as a class society is to get to a place where we can more proactively manage class and really bring that safety benefit to the industry. And so, as I heard some of the remarks, and I think the major topic of operational excellence, I'll offer one more perspective. We think about class as being the ground floor of a maintenance program. So maintenance planning, dry dock planning, optimizing your spare parts inventory, and more ultimately builds on the foundation of class. And so reducing unplanned downtime, improving safety, all of these are key downstream outcomes of an enhanced operational readiness. And we think, yes, AI has a big, big part to play in that. I'm getting a little bit more specific. Some of the goals and objectives, really, when we think about it, it's not about reducing ABS costs per se. It's about delivering other key benefits to our client base. So enhanced safety for class, of course, that's our main mission and our main goal, and we think that aligns with client outcomes. But there are certainly other things that build off of the use of the technology. So we think about, as I mentioned, unplanned downtime, optimized maintenance, and enhanced spare parts management. I would say that, maybe not even 2 years ago, doing any kind of digital technology for operational impact needed onboard or edge computing. And today, with enhanced connectivity, with technologies like Starlink and so many other similar solutions in the market, you can start to now integrate your data, your analytics, all the maintenance operation and compliance into this one-stop shop offboard, making it much easier for the industry, for our clients, to really manage operation from that streaming data that's extracted from the vessel. On a parallel vein, we also have increased remote verification capabilities. It's really kind of born out of COVID to reduce the ABS onboard footprint to make surveys less intrusive. This really unburdens the crew. That's a great thing, of course. But where we see the efficiency gain really relies on huge amounts of data streams. So when you think about remote surveys, we're of course thinking about additional uses of video and photo and all of the additional streaming data that comes off of the rotating machinery, all to inform a better posture for class. And so at that point, AI isn't just to help. It isn't just, kind of the next step. It is really needed to proactively manage and process all of this information. Switching gears a little bit, let's talk about maybe another great use of AI tools, getting to environmental improvements and emissions control. To inform in terms of environmental performance from ABS's perspective, our subsidiary, ABS WaveSight, does offer a suite of solutions that enable tracking, monitoring, forecasting, not only the key regulatory components for sustainability, but also operational. So this is in place to really help the industry manage through all the new and evolving standards. So this is your Poseidon principles, your Sea Cargo Charter, EU ETS, Fuel EU, and beyond. Now, this particular tool suite collects data, maps, and ingests for on-voyage or on-demand voyage verification, which is done really for commercial purposes at a voyage level. But at an annual statutory level, we also will use the same technology for your CII, your EU MRV, your IMO DCS certifications. These tools, again, will include your typical regression modeling for fuel consumption and so forth. But where the AI is really starting to apply in kind of a more sophisticated or more technologically advanced approach is really looking at managing the operation and reducing those scores. So this is where you get your real-time data feeds into weather, route management, and the like. And then lastly, I don't think we can have an AI discussion, and I don't think this is brought up yet quite today, without mentioning large language models. This is, of course, really what many people think about today, the generative pre-trained style solutions that really kind of have captured the imagination of the world. And I think, and we think AI is far more than just LLM. But ABS is using large language models as well. So looking ahead to next year, we're going to be very excited to introduce what we think will be the industry's first AI-powered interactive, we say chatbot, for class and rule-compliant questions. So I remarked in Cameron's photo of the safety management system with all the books on the bookshelf. ABS has some 30,000 pages of rules in our guides, in our guidance notes, and our advisories, and consuming all of that is a challenge, but maybe not for AI and maybe not for long. So our tool is built on OpenAI. It allows questions to be posed in natural human language, and it gives you relevant results. Also connects you to the link to the actual document and a human subject matter experts if you want to go into a deeper dive. So we're really excited about that as something that's in pilot now with a handful of clients, and will be more generally available here in a few months. So with that, I'll bring my remarks to a close. I think we've had some good introductory material, and I look forward to the question and answer and polls section. So back to you, Edwin.
Thank you very much indeed, Patrick. Fantastic presentation, which in common with the other presentations has generated a number of questions. Ladies and gents, do keep your questions coming. Gentlemen, what I would like you to do is catch your breath, give consideration to the many and varied questions that have come in. While our panel are doing just that, I'm going to come to our audience in rapid fire with some poll questions for your account. So ladies and gents in the audience, how do you envisage autonomous capabilities improving your fleet operations? Enhanced crew well-being, lower operational costs, they'll ensure compliance with regulations, strengthen brand reputation, or minimize crew workload. You have 5 options there. I think that what we're asking is, what do you see as the most significant outcome as a result of autonomous capabilities and their potential to improve your fleet operation? So all of these could be results, but what do you see as the most prominent result? So results coming in thick and fast. All bar one of the categories has attracted your votes. That's very, very interesting. I can tell you that in a distant joint 4th place is enhanced crew well-being and strengthened brand reputation. In 3rd place is ensure compliance with regulations. 2nd place, minimize crew workload. but most are saying lower operational costs. It could be our panel choose to reflect on some of these findings a little later on. I'm going to have 2 more poll questions, ladies and gents. You now know how it works. Here is number 2. What safety priorities will your fleet face in 2025? Achieving real-time situational transparency on board, maintaining SMS compliance, improving the results of navigational audits, enhancing training procedures, or in fact, identifying high-risk trends that require proactive action. So what will be the lead safety priority for your fleet in 2025? Let us know how you see it. Nice and lively, please, ladies and gents. I'll just give you the top 3 on this occasion. 3rd place, maintain SMS compliance. 2nd is achieve real-time situational transparency on board, but polling twice as many votes as the 2nd most popular answer is identify high-risk trends that require proactive action. Just one more for your account for the time being, ladies and gents, then I promise we'll tackle those questions. What are your crew management priorities for 2025? The number 1 priority, would it be automating daily tasks to reduce workload, boosting crew well-being through better connectivity, attracting top talent with advanced tools, or offering digital training solutions? They may all be priorities. We're really asking you, what is your top crew management priority for 2025? Just a few more seconds, ladies and gents. I can tell you that in 4th place is offer digital training solutions. 3rd place, boost crew well-being through better connectivity. 2nd place is attract top talent with advanced tools, but the lead response by some distance is automate daily tasks to reduce workload. Right, I'm about to increase the workload of our panel. Here they are. Yarden, what I'd like to do is perhaps come to you first. There's a very interesting one here. How do you see the possible implementation of these solutions in ROCs related to mass? Over to you, Yarden.
Yeah, thank you, Edwin. I will see, just for the ones on the panel and the ones of the attendees that don't know, it's a remote operations center. So situational awareness in terms of remote operational centers, this is something that is growing constantly now for different type of operations. And this is something that is crucial, especially to provide visibility to a remote station that can operate now a specific vessel remotely with some autonomous capability. So I will share an example. OCA is a part of a consortium of companies in Japan working very closely with Japanese government, but also with some of the biggest shipping companies there, including NYK, MOL, and K-Line. And in 2022, we basically did a demonstration for the first commercial voyage that was completely autonomous. No human intervention, with the ability to remote control and send the data in real time to remote control center, including situational awareness data, including ships data, environmental data. And the key there is to create an ability to drastically reduce the workload while enhancing safety and operational efficiency of a commercial fleet. So in this specific case, situational awareness information was sent to the remote operations center and provided indications and guidance for the operators that did it remotely. So it was super successful, and we could actually see that working in action. I think that now connectivity will actually enhance that, because once you have more data, more bandwidth, that you can transfer data, it will unlock different type of remote operation capabilities and use case, everything from just operating different type of ships, doing walking group, and then also, for example, to do use cases like remote pilotage, where when you're entering a certain canal or a certain port. So I think it will enhance operations as we have more connectivity and as AI is progressing as well.
Thank you. Any comments, Patrick? I see you nodding. I presume in agreement.
Yeah, I do. I think we don't call ours an ROC. Ours is called an operational support center, but it's along the same vein. And in fact, we don't obviously operate vessels this way, but we do manage our own fleet, our class fleet, as well as our surveyors, and is where we centralize the performance of remote survey. And as we enter into the condition-based class future, it's where all the data streaming comes in for some of that early decision making I think, as we look to reduce surveyor footprint during an availability, many of those decisions can be made by our subject matter experts in the Ops Support Center, which then informs the work order and really affects what can be done remotely versus a physical attendance. So, I think from our perspective, this concept was really born during COVID, when remote performance was really at a peak, where physically attending a vessel was a challenge, and has really stuck around. But I think in a lot of cases, we do now see opportunity to take that from kind of that center perspective and really kind of deploy it out into the field with mobility and mobile solutions as well. So yes, and to Yarden's comments, I think there's lots of great opportunity through these types of centers.
Thank you. There's a specific question for Roberto. How do you collect, filter, and send the data from the vessels to the cloud, considering the variety of equipment manufacturers out there?
Yes, so thank you very much, Edwin. This is an excellent question, actually. So in terms of the data collection, we are agnostic. We can either integrate with an existing provider that collects information, or we can do it ourselves. In case we do it ourselves, it's quite simple. Each maker and provider have their own interface. So we will interface with a, let's say, alarm monitoring system to collect some data, or on the bridge with a navigation system, and to collect the relevant information. And essentially, we send it to the cloud, depending on the client and how often they want to, from every 5 to 10 minutes all the way to up to once per hour. As we are re-optimizing, especially when we're doing route optimization, we need to be very aware of the ongoing status of the vessel. So that's how it happens. And one thing I should mention is that although there are many different equipment makers, the very positive thing for us and others in the industry trying to navigate through the structure is that they have agreed on some specific interfaces that they export the data with. And that is for us very, very helpful, because it means that it's not for every specific maker a new implementation.
Thank you.
Thank you.
Cameron, an intriguing question for you. How is Scorpio addressing the potential skills gap between AI capabilities and crew expertise, especially on older vessels?
Thank you, Edwin. I think I would reframe the question is that we don't necessarily see a skills gap. We have a time gap. So put differently, we're not expecting our ship staff to become experts in AI or technology platforms to the extent Roberto or Yarden are. What we have, on the other hand, is a situation where different influences and demands on their time crowd out what we view as priorities. So these priorities become mismatched. And so we really have a time gap. And so one of the benefits of some of these systems and new tools is that they can be introduced without so much of the confusion or anxiety or stress I was mentioning in my presentation. They can start to reduce workload. There are other things that we're looking at doing. For example, removing a lot of the administrative work from the vessel and putting it ashore, which is facilitated through the great connectivity we have now. And in this way, freeing up time so that we can redouble our efforts to marry our expectations and our demands with the crew and budget their time better for the demands of an older ship or a newer ship for that matter.
Thank you. This seems to be resonating with both Yarden and Roberto. Anything you would wish to add, gentlemen?
Yes, I mean, just because I saw a question before, and actually quite a few of them, on how AI will, displace the workforce in shipping. I think that this is not the case, at least for the technologies that we are discussing on this panel. But what I expect will change is the nature of the jobs onshore, because currently everything happens manually, for instance, but with the Orcus system, a lot of the element of detecting obstacles, for instance, from the captain or from anyone else on the crew, that can be replaced more effectively, more efficiently by technology. Same with deep sea, as currently the captain has to form an email and understand how the vessel is performing and use that information, or create the optimal path that will not in the future be part of the captain's job description. It will be, I believe, more managerial, more overviewing the situation on the vessel. So I think the nature of the jobs will change. It's not that the jobs will be replaced, is what I am getting at.
Thank you. Let me come to Patrick. As a class society, how has data analytics helped you minimize days in dry dock for your clients? And do you have any concrete examples?
Yeah, great question, and I think that's one of the big benefits many clients are looking for. And really the biggest and most obvious example is that we can move some of the work that is in the physical attendance of survey earlier in the process and into a remote center. And this is where, whether that's streaming data from rotating machinery or streaming video from the crew or photos or whatever the mechanism is, to really move left, move earlier, and move off board some of that survey function. And as we really think about what does that mean from a mission standpoint, I tend to be in the camp and of the strong opinion that we can do a better job enhancing safety with streaming data from a main engine, for example, vice, open, and inspect during a survey. And so not only do we kind of reduce our footprint and reduce the opportunity to be aboard and be disruptive to an owner, we also do a better job delivering on the mission. Or you ask for a specific example, the real kind of early adopter in this program is the United States Military Sea Lift Command, and their whole motivation is increased days at sea. And I wish I could share the specifics. That tends to be not appropriate for public forums. But I will say that the Navy has been continuing to enroll more and more vessels because they are seeing very positive and concrete benefits for their operational availability based on this program.
Well, of course, Patrick, you are among friends, so you can feel free to share this data should you wish to do so.
Yes.
Lots and lots of questions, gentlemen. Let me return to Yarden, if I may. How does the system handle edge cases where multiple vessels are on a potential collision course?
That's going back to the data. So as you're able to collect, record more type of scenarios, ships are getting into ports, exiting ports, different type of weather conditions, different type of visibility, congestion level, areas with fishing, weather conditions. Then you're able to train the model on how the ship actually needs to operate in these type of conditions. And basically create a model that will know how to handle those type of situations. So basically what you're doing is reinforcement learning to a specific model on how ships needs to operate in different locations, different type of the different visibility. And by that, once the model knows how to do that, it will be able to mimic a different type of scenario that is encountered. So you start with the simple cases where you're just providing indications or recommendations or actionable insights to the crew. But this is actually, when you're looking further down the line, this is also creating the infrastructure for autonomous capabilities in a way that once a model knows how to react and how to act in different type of situations, this is what will enable and drive autonomous capabilities in certain different conditions for the future. So what we're doing today, we are building, based on the data we're collecting, models that are already providing and empowering the crew with actionable insights today, but also creating the infrastructure towards replacing them in certain conditions so they will be able to actually reduce their workload, so they will be able to supervise and take action only in more severe conditions.
Thank you. Of course, an important dimension to this discussion is the commercial, and perhaps I could come to Roberto with this next question. How does your system incorporate charter party warranties into its optimization recommendations?
So that is an excellent question. So if there are limitations with a charter party, and therefore the vessel has to navigate at a very specific speed, then we have to comply and navigate within those limits. The good news is that because vessels are very inefficient currently and there is very big speed volatility, even adjusting the speed and keeping it within charter party limits in itself provides significant savings. But I should mention that with most of our clients, because they are either charters themselves or they are operators, so they pay for their own fuel, this means that we have a wider range of speeds that we're able to suggest, and we're not limited by specific charter party conditions.
Thank you. I feel that I'd like to carry on with the commercial line of questioning, so I'll come to Cameron if I may, but others welcome to comment. Quite simply, how much has Scorpio as a group, or the tankers division, as you see fit, invested in AI technologies, and what's the expected return on investment timeline?
We are proceeding with some caution. We have made some investments. I'm not disposed to say how, the dollar sum that we've invested. We have an internal division that also looks at different types of ways AI can enhance our operation. Even the sort of phrase AI, I think, can be easily misconstrued, so we don't use that term internally. We either talk about predictive modeling or large language models to help us gain our efficiency in the office, or different types of performance optimization, for example. So we're doing a lot of different things, but we just don't easily group them under a big hairy term like AI. How we measure the return on investment is we like small, discrete projects, what we call low-hanging fruit, with very tangible short-term returns. And that will give you an indication, because there is, frankly, so much hype and misinformation about what works and what the returns will be. That gives you a very concrete idea of whether you're on the right path or not. I think the bottom line is that we have, and we try to promote internally, a culture of experimentation, that failure is okay as long as you're learning, and so that there will be trial and error on the path to some greater end. That expecting that you're going to embark on some big seamless project that's going to work great and involve tens of millions of dollars is just naive. And so we like to take small steps and let those steps guide us.
Thank you. Patrick, in your comments, you alluded to an important industry step, the AI-powered chatbot. So my question to you is, how does the AI-powered chatbot determine when to escalate queries to human subject matter experts?
Okay, I'm tracking. Good question. So it actually does it in two ways. So when the human poses a question to the chatbot calculates an answer, and it actually will calculate a likelihood that the answer is correct. And so if our threshold at the present is about an 80% likelihood of an accurate answer, if it's below 80%, it goes to a human. And if it's above 80%, then it will go to the user that posed the question. So the first way is that threshold. And the second way is the user then has an option to then immediately say, please escalate this to a human for verification. Basically, today, we're not allowing the chatbot to basically speak for the Bureau. Humans still need to do that. It can be a way to find information more quickly and a way to kind of navigate through the large volume of information. But at the end of the day, the chatbot isn't going to be a ruling entity on any class decisions. It'll still be a human. And so we track all those, and they get escalated by request by the user as well. So those two ways.
Thank you. Gentlemen, I'm incredibly conscious that there are a number of questions unanswered. What I'd like you to do is give thought to your key conclusions and takeaways, and wrap up in your key conclusions and takeaways, perhaps one or two questions that we haven't addressed that you would like to see addressed. Ladies and gents in the audience, while our panel do just that, I revert to you in rapid order with some more poll questions for your account. What proportion of your fleet is currently equipped with high-frequency sensor data collection? Less than 10%, around 25%, around 50%, around 75%, or more than 75%. Nice and lively, please, ladies and gents. We will do 3 poll questions in total and then revert to our panel for their key conclusions and takeaways. Let me just give you the top 3 as I speak. So in joint third is 25%, 75%. Second place is less than 10%. But the lead response is more than 75%. Here's another question for your kind account. It could be, of course, our panel choose to reflect on some of these findings, but the question is, in which performance area would advanced analytics help you the most? Fuel efficiency, weather routing, equipment reliability, emissions monitoring, or hull performance. You may feel that you stand to benefit across all 5, but the question is, in which of those areas would you derive the most benefit from advanced analytics such as AI? Well, very, very interesting voting. It's a fairly even spread. I will again give you the top 3. And as I speak and things do change, in joint second is emissions monitoring and hull performance. Equipment reliability is now actually second. There's been some changing in the voting, but the lead response is fuel efficiency. Final poll question, ladies and gents, and then we will revert to our panel. It reads a little something like this. How would you characterize your organization's current vessel performance monitoring capabilities? Basic in-house analysis, advanced in-house analysis, third-party systems, or no formal monitoring system? Let us know how you see it, ladies and gents. So votes again coming thick and fast. Let me give you the top. Let me give you all the results. There we go. So 4th place, no formal monitoring system. 3rd place is basic in-house analysis. 2nd, but only by 2 percentage points, is third-party systems. But most people are saying advanced in-house analysis. Well, I'm confident we're going to have some advanced in-house analysis, courtesy of our panel, as we come to them for our key conclusions and takeaways. Yarden, you were kind enough to get the ball rolling, so the floor is yours.
Key conclusions. That's right, Edwin?
Yes, please.
Yeah, so first of all, I think that we're embarking on a very interesting period in the shipping industry. We're just in the beginning. We see that just now technology companies are starting to gain a little bit more traction and start to create tangible impact in terms of ROI to their partners, to their customers. I think it's just the beginning to see the use cases and how crews and how fleet managers and operational team are actually using new type of AI technology and utilizing it to create more benefit and to improve ROI. So I'm excited to be here with the distinguished speakers to talk about that, to push the envelope around that. And yeah, it's going to be interesting future. It will be interesting to see how it looks in 1 or 2 or 5 years from now.
Thank you very much indeed. Roberto, we come to you.
Yes, thank you very much, Edwin. So actually, I want to mention a couple of points that, as closing remarks, what Cameron mentioned before, because they really resonated with me. And the first is that I think experimentation is crucial, as said, in order to evolve. And mistakes will, of course, always be made. As long as you learn from them, then it's a lot of progress. The second takeaway is I would like to emphasize is that making the transition to digitalize a fleet can seem like a very daunting task in the beginning. But one of the most important things is to break it down to small projects. And the first very small project is to create a case study with a company and measure for yourself the impact and the ROI that this technology has. You don't need to just believe the claims or what others have said. You can measure it yourself. There are methods in place, I believe, with all of our companies here to do so. And therefore, I think that's a very, very key takeaway. So that it doesn't seem like a very daunting task. Thank you.
Thank you very much indeed. Cameron, we come to you.
Thanks, Edwin. 3 related points, and taking further what Roberto was saying. For those that are working in the industry, I think what we have to focus on right now is that technology, whether we call it AI or otherwise, these enhanced tools are facilitating your job. They're not replacing your job. Related with that, what these technologies have the potential to do is making different tasks, individual tasks, more efficient, and thereby making an individual more effective. We don't necessarily want individuals to become more efficient. We want the flow of information and the way they do their jobs and some of the more menial tasks and repetitive tasks and some of the decisions that might involve vast computational capability to just be done more efficiently so that they themselves can be more effective in their position. And the last point related to that is there's a difference between things that are complicated and things that are complex. These tools are complex. The job on board doesn't have to be complex. It can be complicated, but that, as Roberto was mentioning, can be broken down into individual tasks that can be done with thoughtfulness and the good use of time and judgment, which is at the end of the day something that is irreplaceable on board.
Thank you very much indeed. Patrick, the floor is yours.
Yes, thank you, Edwin. So I jotted down a few things as we went along, and when Yarden was presenting, he observed that there's not one feature or capability for this technology. There's lots of opportunity, and that is a takeaway that I echo. I think that's spot on. Then another one, I think was Cameron's quote. He said, "Optimization doesn't work well with ambiguity." And here, I think Roberto talked about that as well, with the quality of the data being critically important to the performance of the systems, and he observed some different error rates based on different functions. We've recently put out a verification and validation guide for digital twins, but more broadly for AI use, and it's something that we're keenly aware of. And having good quality data is a very important takeaway from this. And then the last of the three that you asked for comes from one of the earlier set of polls. One of the winning questions or winning answers was a focus on AI to reduce high risks or to identify high risks trends that require action. It's very gratifying for me to see that from the audience. I would agree that reducing human error and identifying opportunities, whether it's for simple things like port state control or more important things like saving or reducing risks of impact to human life and property at sea is really what we want to be all about using this technology. And I'm glad to see a great alignment with the audience.
Thank you very much indeed. We themed this webinar, Driving Operational Excellence in Maritime Challenges and Innovation. I'd like to thank the panel for showcasing their operational excellence as we've tackled complicated and complex matters, but in a very lucid and understandable way. So Yarden, Cameron, Roberta, and Patrick, thank you very much indeed. As you know, ladies and gentlemen, with Riviera, there is always more to come. I'd like to share with you what's on the agenda. So coming up in the not too distant future, we have, in fact, this week, an event on offshore support vessels in the Middle East. We are variously doing webinars on maritime regulations. We're organizing Gulf days and much more besides. To keep abreast of our evolving schedule, please scan the QR code on your very screen. Now, ladies and gents, I know that corporate social responsibility is important to you. It's certainly important to us. And with the holidays coming, I'd just take a moment to promote a recipe book with a purpose that we are producing. Proceeds from that book are funding a maritime conservation scheme. If you wish to know more, please feel free to contact me directly or go on Amazon and purchase one or more copies. Of equal, if not greater relevance, is the source of the virtual webinar library. It is here, ladies and gentlemen, where we will be housing today's recording and materials, and it is here that you can access recent and not so recent webinars on demand and in your own time. In order to access this treasure trove, it's really quite simple. All you need to do is register. To register, simply visit any webinar, any Riviera homepage, locate the blue bar at the top right-hand corner, click on it, draw down the simplest of forms, complete it, and half a minute later, you too are part of the community. We serve our communities information that matters in a variety of guises and formats, including weekly newsletters, magazines, curated content online that matches your interests, and by producing relevant events such as this. The only action required on your part, ladies and gents, is to register, which you can also do via rivieramm.com/registration. Well, that is us at time. Again, the hugest of thanks to Yarden, Cameron, Roberto, and Patrick for sharing their expertise and insights. The hugest of thanks to you, ladies and gentlemen, for joining us from all over the world. Let us know how you found it by completing the form, which you can access via the link in the chat. Let me also underline the huge appreciation we have for our sponsors, Orca AI and Deep Sea. So thank you, Orca AI, Deep Sea, and all concerned. Wherever you happen to be in the world, ladies and gentlemen, please do stay safe and well. And until we next convene, good morning, good afternoon, good evening, and for now, goodbye.